Hello everyone, it's Sajjad, and today we're going to solve another Leetcode problem. Problem 5, longest palindrome substring. A palindrome is a string that could be read from the beginning and from the end the same thing. So for example, in this case, BAB is a palindrome, but BAD isn't a palindrome. By definition, each single character is also a palindrome. This problem wants us to find the longest palindromic substring in a given string. So in the first example, BAB, ABA are both candidates for the answer. And in the second, BB is the only candidate. So whichever one we return in our function, it would work as an answer. The length of the string is between 1 and 1000. Letters are all English letters and digits. So without further ado, let's jump to the solution. Our solution for this problem would be to iterate over the entire string character by character, and from each character we know the single character is a palindrome. So we start expanding from both directions and figure out if the current character with the neighboring characters would create a palindrome. So there's two cases that we should handle. The palindromes that are in even sizes and palindromes that are in odd sizes. And let's go to the implementation and I'll explain what I mean by that. So first, we're going to create a function which would expand a string from a given character. And we're going to give two pointers to expand from that point. For this problem, it would be expand from middle, and it's a string which we are getting. The left would be the index of the left character, and right would be the index of the right character, which we're going to expand from that point. And at the end, we're going to return a data structure that would consist of three parts. Number, this is the left of the result palindrome, number, and for simplicity, I'm going to return another number, which is the size of the palindrome. And why I'm doing that? Because I'm not going to recalculate the size over and over again. It makes it simpler for implementation purposes. So do left minus minus and right plus plus, expanding it both at the same times, but until when? While the left is greater or equal than 0 and the right is less than s dot length, and last but not least, s right is equal to s left. Makes sense, because in a palindrome these both ends should be the same thing if it's going to be read from the beginning and the end the same thing. And if this applies, we would return the left plus 1, because we actually went one character before our condition applies. So we met a place that it's not valid anymore. And obviously the right has the same condition. And the length of it would be right minus left minus 1. I think that's quite easy to understand. Now that we have the function that could expand the character, we could easily implement it like this. Let max palindrome be, it's going to be the same thing, a number, and a number. For comparison reasons, this is simpler. At the beginning, the index of the left of the palindrome, the index of the right of the palindrome, and the size are initialized like this. Then we're going to iterate over the string. And for the odd palindromes, so this is the palindrome that starts with the character. We go both ways at the same time. So expand from middle would be S, I, and I. Now there's going to be a local maximum, which for now is the same as the odd palindrome, which at the worst case could be just one character. So if I is smaller than s dot length, meaning that there is another character after the current index that we are currently on, -1 actually, and si is equal to si plus 1, we know that there might be a possibility of an odd palindrome, of an even palindrome. An even palindrome, at the middle, both characters are the same. So if this happens, which two consecutive characters are the same, we start expanding from that point. So let even palindrome be equal to expand from middle si and I plus 1. Now we have if max here, local max, we called it maximum 2. Remember, we decided that the 2 is the size of the given result, is smaller than the even palindrome size 2. Again, the size of the palindrome, the length of it. We could do a calculation of subtracting, but for the sake of simplicity, we're just going to check the second index for now. Then the local maximum would be the even palindrome, right? So now we have to compare it with the ultimate maximum palindrome, which would be maximum palindrome 2 if it's smaller than local maximum 2, then the maximum palindrome is the local maximum. And I believe that's easy to understand. But so s dot substring from the maximum palindrome 0 to the maximum palindrome 1 plus 1. This is the result of the longest substring. So let's submit it and check the answers. Okay, seems like we have a problem. Let's try to resolve it. Oh, okay. So for now, we see that there's a typo here. We meant number. So let's run the code again. It passes these test cases. Let's submit it. And yes, it's accepted. Hope you enjoyed this video. Please give a thumbs up, write any comments. I would appreciate any kind of feedback. And if you're interested in solving other programming challenges from my channel, please visit one of these other 2 programming challenges which are suggested. See you in the next one.